Sir Kannan Gopalakrishnan. He was working as a senior architect at Engineering Design Research Centre, L&T Construction, India's largest construction company. He's also worked on projects ranging from institutional buildings to international airports, apartment complexes to aircraft hangars. He's also attended 3 international conferences and 2 national conferences, and has also presented technical papers at the Jawaharlal Nehru University, Delhi, and the MSRIT, Bangalore. He's also won the national championship at Archaman at the India's largest architecture quiz. Sir Kannan Gopalakrishnan currently runs a design firm, Habitat Design Studio, and he is also a visiting faculty at the renowned architecture schools in Tamil Nadu.
Welcome back to UGC lecture series. This is AR 6502, History of Architecture and Culture 5. We are in Unit 1. We are looking at leading to a new architecture. This is lecture number 9, and if you remember the previous episodes, in this series we saw industrial revolution and the rise of cities and urbanization. Today we are going to look at some 19th century architecture, bridges in 19th century, modern technology, materials in 19th century. If you look at 19th century from an architectural point of view, there was no one style which was predominant in 19th century. We cannot say that there was one style which was predominant in 19th century. Buildings were often recognized by the function rather than their style. From the 19th century buildings, if you want to say, okay, this building is a 19th century building, what would you first see? You won't look at the materials, you won't look at their looks, you won't look at how they look. What you actually see is you first look at the function of the building, and then you can probably tell, okay, this is a 19th century building. Well, some buildings were designed in a single particular style. For example, some buildings were designed in a neoclassical style, some buildings were designed in neo-Gothic style, some buildings followed the traditional Romanesque and the Gothic style for cathedrals, some buildings followed clearly the Renaissance style of revivalist style. Some people followed the Baroque and the Rococo styles, yes. They followed the rules and rationality pertaining to that particular style. Whereas some other buildings, what happened was they did follow one style, so they borrowed elements from a lot of styles and they blended it all together, and you get a style that was a mixture of all these styles. So you take elements and things from all the things, you put it in a mixer and then you churn it, and then your building is produced. This kind of architecture became more relevant to 19th century than buildings that were actually built of one particular style. So that is the reason why 19th century did not have a particular style of its own. They also had certain trademark styles of structures. For example, churches need to be done in neo-Gothic style. Civic buildings means, okay, neoclassical style is the right thing for you. So they had these trademark things that were associated with certain typologies of buildings. Certain typologies needs to be built only with certain types of style. And there was another thing which was very, very prominent in the 19th century. The decorative motifs which people were using. So far in the previous architecture styles, the decorative motifs were actually made every single thing, but in 19th century what they did was they started mass producing all these decorative details. The rise of factories and industries, thanks to them, they started mass producing all decorative details. Your window grill detail, your door detail, your column capitals, your lanterns, lighting, all those things started getting mass produced, mass manufactured. So if you want a particular style and a particular motif, that motif was available in numbers. If you want 100 types, 100 of those motifs, it was available for you. Such was the power of industrial revolution and impact which it created to architecture in the 19th century. Let us take a look at metals, role of metals in architecture. Before 1800, the metals performed majorly an auxiliary role because they were used for bonding masonry such as dowels and clamps. They were used for tension members, chains, sometimes strengthening domes, sometimes rods across arches to reinforce the walls, yes. Sometimes for roofing, sometimes for doors, windows and decoration, sometimes to fix two pieces of wood together, they put a clamp and then they start bolting them together or riveting them together. Sometimes they used iron for decoration. But 19th century saw the first use of mass usage of iron, not just in an auxiliary role, but also as a primary building material. So, that was the major thing in 19th century. If you think, okay, what is the major thing in 19th century? They used all the styles, they didn't have a style of their own, they started mass manufacturing things. So, what is the important thing about 19th century? If you ask that question, so this is probably the answer. They started using iron for as a most important material, as the fundamental material in their buildings. Wrought iron was invented. Wrought iron is a low carbon malleable metal by producing iron and charcoal to form a bloom. It is a spongy mixture from which ash and other impurities needs to be removed by repeated beating and folding. You beat and then you fold again. So, you do this process repeatedly and you get wrought iron. And let us take a look at what was available at that point of time in 19th century. You had brass, had aluminum, you had cast iron, copper, you had steel. Steel was produced later by mixing cast iron and wrought iron together. You had bronze, then you had something called metal sludge. If you see this picture, you can see Williams and Co. There is a metal manufacture facility. They produce boiler tubes apparently. They produce different types of metal products, and this is how a typical 19th century factory building looked like. They had very huge prominent way in which they brand themselves. The branding was so loud and clear, and the building automatically shouts out. The moment you look at the building automatically shouts out, even if it is not written here, shouts out that it is a factory. In 19th century, iron was available in 3 different forms. The least processed of all the 3 is the cast iron, which is very brittle. It has high percentage of impurities, but yet it displayed impressive amounts of compressive strength. Second is the wrought iron, which is a little more refined form of iron, malleable, low tensile strength, not very high tensile strength, but good compressive strength though, because it is more refined and it is more malleable. Wrought iron is formed by burning coal and things together. We just saw the previous thing. Wrought iron is produced by mixing iron and charcoal together by burning them and then clearing off all the impurities. Finally, steel was produced, which had very high tensile and compressive strengths than any other previously made material available, and its capabilities revolutionized the way we look at architecture. Steel and concrete are 2 materials that entirely revolutionized the way we look at architecture. If there is something called architecture revolution, we must attribute it to steel and concrete. That is the revolution in architecture. Okay, let us see if what is the first thing that was produced in iron. There was mass manufacture, that was used in large amounts, and there was the most useful component in the life in 19th century, that was the rails. People made tracks, train tracks out of iron. This was the first basic unit of construction. They made rails, and they also had this feeling in the mind that iron was not something that you need to use for houses or churches. They were usually used for arcades, exhibition halls, railway stations, civic buildings, public buildings, large scale buildings, not generally used for houses and churches or palaces. This was not the kind of material, because they thought iron was cheap, iron was not so sophisticated for them, and it was meant for these kind of buildings. That is the mindset. Cast iron was first used in a bridge building as early as 1779. This is engineer Wilkinson was assisted by Darby and an architect T.F. Pritchard. They designed and erected the first cast iron bridge, which is a little more than 30 meters. It was built in Colebrookdale in 1779. As early as 1779, the first cast iron bridge was built. It was not even in the 19th century, it was in the 18th century. In 1796, Thomas Telford made his debut as a bridge builder by building a bridge that was close to 40 meters. From 30 meters in 1779 to in 1796, we had a 40 meter span bridge. Then there is this person called William Strutt, who built a cotton mill that had 6 floors at Derby in 1792, late 18th century. And there was this Charles Baige, who designed a flax milling mill. It employed cast iron columns. This flax spinning mill, what it did was, it had columns that were completely made of cast iron. Instead of traditional brick and plaster columns, they had employed cast iron columns. They shed the traditional use of stone and brick, and then they started using steel and iron for columns. If you are wondering how this Colebrookdale Bridge looks like, which was built in 1779, this is how it looks. It's a beautiful bridge made of cast iron, made it to form an arch, and the bridge works just fine. You have piers on either side of this Severn, and this span is a little more than 30 meters. There is this arch that spans the 30 meters, big huge arch, and people can go over this bridge over here. This is the bridge that Thomas Telford designed. The Crystal Palace. The Crystal Palace is not technically a palace. It was called a palace because it was a huge building made of glass and iron. It was built by Joseph Paxton at the Great Exhibition of 1851. It was a very early example of iron and glass construction. There was iron elements and glass panels which were supported between iron elements, and the entire house was built by iron and glass. Cast and wrought iron products have been used extensively in buildings since, especially in the 19th century, but were largely superseded in the beginning of 20th century by hot rolled steel members. Even though in the 19th century cast iron and wrought iron were very widely used, when the steel came, it swept all these things. When the steel came, people no longer built with cast iron or wrought iron. Cast iron and wrought iron were not used for building after steel came. If you are wondering what Crystal Palace looked like, this is how it looks. This is the picture of Crystal Palace before it was taken down. Wrought iron masonry reinforcement in France had its origin in Paris, because in Perrault's east facade of Louvre Museum, and Soufflot's portico in Saint Genevieve. In France, in the Louvre building, the Louvre Museum, the east facade had a wall made of masonry, but it was reinforced by wrought iron. This was a revolutionary improvement in use of iron in building industry, but this was very early. Perrault's use of wrought iron in Louvre Museum was very early. It was revolutionary. Soufflot's portico in Saint Genevieve also used wrought iron. When Victor Louis also used wrought iron roof for Theatre Francais of 1786 and theatre in the Palais Royal. The roofs of theatres were used to be built by wrought iron because of two important reasons. First thing is, in a theatre, the most important thing is not the roof, the most important thing is the stage. So, if you use a material such as wrought iron, nobody will really care, because people would be more interested in what is happening in the stage rather than what is happening on the roof. Number two is, if you want to span such a big audience such as a theatre, because in a theatre there is a large congregation of people, and if you want to span such a big span without columns in between, because the moment you add columns in between, the visibility will become very difficult. So, if you want to do something without columns, the only means at that point of time was wrought iron, because otherwise it was very difficult for people to make this possible. James Finlay, an American, he invented the stiffened flat deck suspension bridge in 1801, more than 215 years before. He invented the stiffened flat deck suspension bridge. Suspension bridges are types of bridges where the main roadway or the thing that carries the motorized vehicles or pedestrian people, That surface is suspended from cables which are coming from the top. So, this is that building, this is that bridge. This is the house where James Finlay was born. Britton Brown's wrought iron flat bars were used in the Union Bridge. Then they started making flat bars of wrought iron, and these bars were used in the bridges. The wrought iron suspension construction bridges started in Britain in 1829 in Bristol by Brunel Clifton Bridge. Here suspension bridges were very new to Britain, because it was only invented in 1800 by in the America. In 30 years it has come to Britain. Stephenson and Fairbairn Britannia designed the tubular bridge. It is a over the viaduct. It had plated wrought iron too. Plated wrought iron, previously people were using flat bars of wrought iron. Now they started making plates of wrought iron which can be made into tubes, and Stephenson and Fairbairn designed the tubular bridge. The Britannia bridge comprised of iron plated box tunnels which bridge the strait in 70-meter span. When in a period of time where iron was only used for utilitarian structures like bridges and other things for buildings that need stiffening in between inside the buildings, bridges were only used for those kind of things. In 1889 things changed drastically when the Paris Exposition happened, which had the Eiffel Tower, which was designed by Gustave Eiffel. It had an overall height of about 300 meters, was completely made of iron, not even cladded, and a tower structure which was completely made of iron revolutionized the way people started looking at the material. First they thought it was a scar on the face of Paris, because it was so ugly, considered to be so ugly, because nobody liked iron, and iron was a cheap man's material, and iron was a material that was meant only for bridges and other utilitarian things and not for things that were supposed to be beautiful. Industrial exposition is a place where people learn about different kinds of businesses and different types of inventions about, and from people from different countries participate in that. And to produce such kind of a building in an exposition, world exposition, was scar on the face of Paris according to a lot of people. Later Eiffel Tower became the world's most famous building and one of the most famous attractions, and today Eiffel Tower attracts the world's maximum number of tourists. So, what was the scar on the face of Paris is now the pride of Paris, because it attracts the most number of tourists across the world. So far steel was only used sparingly. Mostly bridges were done with cast iron and wrought iron. The first major structure which was entirely built of steel, a cantilevered bridge, was the fourth bridge in Scotland, not the fourth bridge, but FORTH, fourth bridge in Scotland in 1890. This is how the bridge looks. The portion that is cantilevered is this portion. This is a cantilevered building, and if you were wondering how this is even standing, these two are huge piers, and from these piers rise arms. These arms in turn support this pier. First, when people designed this bridge, when the designers made this bridge and showed it to people, people were not very happy. People thought, no, there is no way that this building is going to stand. This bridge defies all known laws of bridge making so far, and this building is not going to stand. And people were criticizing the design. Finally, the main lead engineer made a presentation to the people. The lead engineer was Benjamin Baker. Benjamin Baker is not in this picture. He made a famous demonstration on the Queensferry. If you take a look at the picture behind the scene here, this is an elevation of the fourth bridge, which was drawn by the engineers, and look at how the building is. This is the pier, and these are the two arms. This is that cantilevered portion here, and they have the exact same thing drawn in elevation over here in simpler form. So, what actually is happening is, this demonstration was staged in the Queen's Ferry by Sir Benjamin Baker of the structural principle of the Foch Bridge. The weight of the engineer Kaishi Watanabe in the center. Kaishi Watanabe is the engineer who is sitting in the center. There is this wooden plank on which he is sitting, which is not supported anywhere. This is not supported from the back, it is not supported from the ground. He is actually sitting on the plank, which is not supported anywhere, supported by the arms of the men on either side, which is acting under tension. These people are holding sticks like this. Their arms are in tension. Tension means pulling force. So, the weight of this engineer is pulling down, which means their arms are getting stretched from their bodies, but to prevent them from stretching from their bodies, they have introduced another thing, a rod which is attached from here. This rod prevents this arm from stretching. These rods act in compression, these rods act in tension. This is compression, tension is here, and with this action they were able to demonstrate that there is a pier in which is grounded. They are showing with a few bricks there is a pier, and these two arms are these two lines. This man who is sitting here represents this pier, this man represents this pier, and the same way these two arms are here, and the central portion, which is actually the cantilevered portion, is what is here. So, which means they demonstrated that this portion of the bridge does not need a direct base. So, it need not be supported anywhere here, it can simply be supported from the pier themselves. This is the demonstration for the Foch bridge, and this is how it looks. It exists even today in a good condition. The Eads Bridge is an arch bridge over the Mississippi River at St. Louis, Missouri. It was designed by an engineer called James Eads, and the bridge is named after him. It was completed in 1874. This was the first steel bridge in the United States. At that time, when the Eads Bridge was built, it was the longest structure in the United States to be ever built, and that building was a steel building. Eads Bridge has three main spans. The center span is the longest, which is about 160 meters, and the spans on either side of the center span is 153 meters. If you are wondering what the building looks like, this is how it looks. This is the center span, which is 160 meters, and these two are the side span, which are a little less in span, but pretty much the same principle and pretty much the same concept. This is an arch bridge wherein the steel is bent to form an arch on this pier, and there is a road that runs on top of that. John Roebling and Washington Roebling designed and built the Brooklyn Bridge, which at the time of its completion was the world's longest suspension bridge back in 1883. It had a main span of 486 meters, close to half a kilometer. Span of 486 meters, world's longest suspension bridge at that time. This is how the bridge looks. The completion of Brooklyn Bridge was a landmark thing, because it was a landmark achievement, because this marked the beginning of a 80-year-long period of large scale suspension bridge design in the US. Suspension bridges of different spans, larger spans, higher suspension bridges were built in the next 80 years only because Brooklyn Bridge was possible, thanks to John and Washington Roebling. Next, we must look at a very interesting personality called George Fuller. His innovative steel cage system for buildings has a beautiful steel mesh cage for the building, and then he supports masonry units around the steel cage buildings, because the buildings can be very strong, and it can be built with enormous number of floors. That was his idea. It involved a unified steel cage or a framework to support the weight of the tall buildings. And he also created multi-story factories and skyscrapers. He is considered to be the father of modern skyscrapers. The masonry bearing wall was transformed to the steel frame. The building skeleton could be erected quickly, and the remaining components just hung on it so that the building looks complete. On the right hand side of this screen, you see a building which is called a flat iron building because it looks like a flat iron box. So, it is called a flat iron building. It's a triangular building with a very, very small acute angle. This building was also called the Fuller building in commemoration of his name, in commemoration of his contribution to architecture. So, let us take a quick look at what we learnt in this video. We tried to understand the architecture of 19th century. We learnt that the style of 19th century is actually no style at all. We learnt the different kinds of materials that was available. We learnt about the different types of iron that was available, different forms of iron that was available. We saw the different types of bridges, different materials, and throughout 19th century we saw the different people who helped in carrying out great advancements to structural engineering and architecture and bridge building. With this, we should be able to answer these following questions. Why did 19th century not have any style of its own? Explain the different types of early bridges and the need for bridges. Explain the different types of iron and its applications. I look forward to sharing more information with you on the other side of the other episodes. So, thank you so much.